Hello and welcome back everyone to yet another lesson in Python programming. The focus for today's lesson is exception handling, otherwise known as error handling in programming. Now the objectives for today's lesson is as follows. First, we'll briefly define exception handling, and then we'll move on to a practical demonstration where we'll learn how to catch errors using exceptions. First off, let's briefly take a moment to define exception handling. Now, exception handling is the process of detecting and responding to errors or exceptional conditions that may occur during the execution of a program. It is an essential aspect of programming as it helps ensure the programs are robust, reliable, and maintainable. In programming, errors can occur due to a variety of reasons, such as incorrect input, hardware failure, network issues, or bugs in the code. To handle these errors, programmers typically use a combination of techniques including exception handling, logging, and error messages. When it comes to exception handling, there are certain keywords reserved to log our errors. This includes things such as the try keyword, the except keyword, the else keyword, and lastly, the finally keyword. Now with that said, let's explore the use of these keywords in greater detail as we carry out the process of exception handling. Now, once you've booted up PyCharm, we can get started. So first, I'm going to create a new project over here. I'll make sure that my interpreter has been correctly allocated. And next, I'll allocate the folder to which I'm going to save this project. I'll create a new directory over here, and I'll simply call this lesson 2. I'll then click OK, ensure that I've highlighted this folder. I'll click OK once more, and then I'll simply go ahead and click create. I'll also open this up in a new window. Great, so we have our boilerplate code, and I'll simply delete all of this code because we are not going to be using it. So let's start off by creating a simple hello world print program. So I'll create a variable called x over here. I'll set this equal to hello world, and then I'll simply go ahead and print this out. I'll print x. Now I'll run my code and I should get the output hello world as expected. But what happens if we simply just decide to print x if x was never available? So I'll comment this out, and you'll notice we have a squiggly line at the bottom of here. I'll run this again, and now I have some sort of error that's being thrown. Notice that this is called a name error. That is the type of error being thrown here. And what this simply means, name error, implies that the variable you are trying to print or perform an action on does not exist. This holds true for functions and modules as well. However, if I uncomment this line over here and I run this now, everything works just as expected. But what if we wanted to catch the error and provide an alternative output as opposed to the error message we received at the bottom? Well, we can simply use a try and except block of code. So just below the variable x that I created, I'm going to type try colon. Indentation is important as well. Then I'll print something which is going to be x. And if x is not available, I'm going to accept. This is the alternative block of code that needs to run if an error is being thrown. I'm simply going to print on a new line over here. Oops. An error has occurred. Let's just provide some spacing over here. And now if I run this code, everything is going to work as expected. I can also remove the final print at the bottom over here. And what we should get is hello world, because x has been assigned a variable, therefore x does indeed exist. So if I run this, we should receive hello world. However, note that if I remove this over here, if I comment this line of code out and I run this now, instead of that nasty error we had previously, we have an alternative message being printed as a result of the except block. So what exactly is happening here? Just to reiterate, first we try some sort of code. If this code fails, we then fall into the except block over here and we print the alternative message. So let's try something slightly different. What if I wanted to catch a specific type of error? In this case, a name error. I'm going to leave the code as it is over here, and underneath my try block where I've printed x, within the except line of code, I'm going to accept name error, and then I'll provide a different string over here. I'll simply say variable x is not defined. And then on a new line, I'll write a new except statement, and I'll simply accept to say that I would like to print a string such as something else went wrong. Now we already know that this is going to produce a name error. The idea behind this is that if we know the type of error that might occur, we can catch that specific error and produce an alternative message or output. So if I run my code now, I should receive the output variable x is not defined. So what are some of the other types of errors that we can catch and produce alternative outputs for? Let's take a look. First, I'll erase all of the code we have over here and I'll start fresh. I'll import the math module, the built-in module that comes with Python, and then I'll create a new try block over here, and inside of this try block I'm going to create a variable called x. I'll set this equal to math dot square root, which requires a parameter. In this case I'm going to enter -100, and then I'll print x, and then I'll write my except statement, and I'll try to catch a name error. And in the event that I do catch this error, I'll simply rewrite the previous statement we had, and that is to print variable x is not defined. Wonderful. So let's run our code and see what we get. Now notice that when I run this code, I receive a different type of error. That is math domain error, and that type of error is value error and not a name error. The reason for this is because you cannot pass a negative number as a square root. This simply doesn't work. However, if I remove the negative sign over here and I run this code now, everything works as expected. So how can we catch the value error? I'll replace the negative sign over here, and just below my print statement over here, I'm going to accept once again, and I'll accept a value error instead. And then I'll simply print out some sort of code. So I'll print a positive number expected for square root operation. Now, if I run this code, we have a different output, and that is because we caught the value error. Now, the value error is raised when the wrong value is assigned to a specific object. This can happen if the value is invalid for a given operation. So let's take this one step further. Let's assume the edge case where the user does not pass in an integer, but instead decides to pass in a string like the letter A or even hello world. Then if I run this code now, I should receive a different type of error, and that is the type error. And that is simply because you cannot pass a string in where an integer is expected for the square root function of the math module. So much like we've resolved the value error as well as the name error, we can also run an except statement for the type error. To do this, I'll simply just accept a type error, and in its place as an alternative value or output, I'll simply print variable x is not an integer. So if I run this code now, everything works just fine, and I managed to catch that error and print out an alternative string. Now let's turn our attention to the else keyword within error handling. I'm going to erase all the code we have over here, and I'm simply going to try to print hello world once again, hello world, and I'll accept that if an error is raised, I'd like to print a simple string that says something went wrong. Great, so let's run this code. Now if I run this code, hello world works perfectly fine. However, if I decided to add an integer here, like 1 for example, without converting this to a string, I should receive an error that says something went wrong. When we use the else statement or the else keyword, the else block of code will always run as long as no errors were raised in my code. So if I remove the +1 over here and I add an else statement, and this is just to print a string that says everything went smoothly. If I run this code now, we should see hello world as well as the everything went smoothly output. So if I decided to add an integer here once again and I run this code, we get the exception being raised. So do keep in mind that when it comes to the else keyword, the else statement will run alongside any other code that is supposed to be executed as long as no errors are raised. Let's do one more example where we focus on the else keyword. I'm going to erase all the code once again. I'll create a variable called x. I'll set this equal to 5. On a new line, I'll create a variable called y, set this equal to 5 as well. Then I'll simply try to print the sum of x and y. That is to say, x plus y. I'll try to accept an error, and this is going to be of type error. And if this error does occur, I will simply print a message to the screen. You cannot add a string and integer. And then I'll call finally right at the bottom, and I'll print once again the code has completed execution. Great. So let's run this code and see what the output looks like. So if I run this code, we have an output of 10, which is the result of this print statement over here, x plus y. And we also have a second output. The code has completed execution. But what happens if we try to force an error? So what I'll do is I'll convert the integer 5 into a string. And if I run this code now, I have an error message over here, which is the result of this type error over here. And I also have the code as completed execution output as well. The reason for this is because the finally block of code will always run regardless of whether or not an error has been thrown. This is quite the opposite of the else keyword. And that is it for today's practical. So to summarize today's lesson, we learned all about exception handling. We learned how to use various keywords to catch errors and try different blocks of code. We also learned about the various types of errors that we can catch and provide alternative outputs for those various types of errors. In our next lesson, we're going to focus on user input with Python. In fact, during our next lesson, we're going to learn how to build a simple food ordering system. So for all of that and more, I'll see you in the next lesson. Cheers.